Hello everyone, welcome to my channel. And I thought to take participate in the Kaggle competition, which is an interesting. So I participate. So let's get into the Kaggle competition, so that even you can get participated in the Kaggle competition. So this is the house prices advanced regression technique, and you need to predict with the random forest and gradient boosting. So here's the sample. You can see. Uh, so it will give you the train CSV, the test CSV, the test description, and the sample submission, on which format you are going to save the. Okay, so you can see there is the text description, sample, and so you need to download this all. Okay, before this I will show you my score. Okay, my submission. Okay, I can show you. Yeah, I have scored around 0.13417. Okay, you can see my ranking. Okay, where's my ranking? Let me just go jump to it. Okay, this is my ranking. My ranking is around 1190. Okay, that's pretty well. So if you want, then you can improve more. Actually, I haven't done the feature selection, from which I need to take and which features I need to disband. So let's go here. Let's go to overview. Okay, and evaluation. Okay, so our goal is to predict the price for each house for each ID in the test set, and you must predict the value of the sale price variable. Okay, and they will be measuring your score on the basis of the root mean squared error between the logarithmic of the predicted value and the logarithmic of the observed sale value. Okay, so actually I have already downloaded. So if you want, then you can download. Okay, so without doing any delaying, I will show you how I have done advanced housing price. And here you can see I have imported the important libraries, the pandas, numpys, Seaborn, and Matplot and Seaborn for the visualization, and numpy for the numerical calculation, and pandas for the manipulation of the data. So at first we are loading our data sets CSV file, and I have saved here. You can see uh, df underscore 10, and I have saved the 10 dot csv df underscore test, and I have saved it in the test, and we are checking the shape of the test and training csv. So you can see the size of, so the shape of train is 1460. It has 1460 number of rows, and it has 81 column. That's a huge dimension. And you can see again there is df underscore test, and it has the similar, which is like 1459, and with the 18. Actually we have one more, that's called the shape. Sorry, we don't call it shape. It has one more row, that is the sale price. So so we need to take a look at the data description, and even you need to take a look at the data description always, so that you can increase your accuracy. So they have described here the data. It has the categorical variable and the numeric variable. You can see it has the lots shape, general shape of a properties, regular, slightly irregular, moderately irregular, regular, and you can check. It has given a lot of information, and for doing this I have maybe I have gone through around 2 to 3 hours. Even you need to do a nice. So it is very important to gain a good score if you want to have a high accuracy in the data. So you must study this data description always. Before doing anything, just go and check the data description. What all these things about. If you have a good knowledge of data description, then only your model will score better and perform better. So let's go into our notebook, and after this we are concatenating the both the training and testing. You can see I'm writing pd under pd dot concat. The concat is the function of the pandas, which is used to concat the different rows, sorry, different column. And here I am, and here I have concatenated the train and the test on the basis of the rows. You can see 0 means concatenating by the rows, and 1 means concatenating by the column. So now you can check the shape. Our newer shape is like 2090 by 81, and it has still 81 column. That is the sale price. So let's go into the information of the data frame, our new. So it has the column first something something. Okay, you can see. Okay, so you need to take a nice look at this, because data information is very vital thing. It's very important. So you can see in the first FLRSF, we have 2919. That is the same as the column, so there is no any missing data. Even in the second, there is no any missing data. In the third, there is no missing data. But you can see in the alley, there is only like 198 non-null value, which means it has its column is only filled by 198. So we don't need this kind of data frame, because there is too much null value. And you can see the bedroom. Okay, there is no null value. It has this much of non-null value, and they have given its data types. Even you can see, if you go a lot, then you can see you can get lot of information. Even in defense, it has 571 only. In the 2919 it has only around 571 field data. And even you can see in the fireplace extinguisher, even it has around maybe around 40% of that 40% of the data are missing here. Even is there any lot of, yeah, there's a lot of null values. So we'll be handling this. And even you can see miss features, and here it has only 105 field value, and rest of the things are just the null or non value. Okay, even you can see in the pool QC. In pool QC it has only 10 values in that column. So definitely we need to remove this, and you need to go to, and this is sale price. Right now I don't need the sale price, because it has only 1460, and which is basically okay. Let's go by the heat map, and you can see in the sale price, where the sale price it should be have. Okay, in the sale price, and this is the sale price. Yeah, I think this is the sale price. So you can see its half value is empty, because in the test data it doesn't have the column price, sale price, but in the testing data it has it has the sale price. So we'll be removing that, because right now we are cleaning our data. So I have done a heat map, you can easily see. Actually, I have told you about that alley has a lot of this, the okay miss features, pool QC, these all have a lot of null value. So let's check into the alley at first. So in the alley first, I am just checking the amount of a null value it has. So it has around 27 to 1 null value, and which is a huge number, so we'll be removing it. Okay, so you can see syntax df dot drop alley dot axis 1 means it will drop by the column name. Even in the fence it has 2348 null value, so we'll be removing that also. Even you can see in the miss features it has around 2814, and which will be removing it. And even the pool QC it has 2909, which is a huge number, so we'll be removing this. So we have removed all. And even you can see the id. Actually id is like a, it's a meaningless, so we'll be removing the id, because these are the id independent variable, and I don't think that this will really impact into our prediction. So I am removing the here, and let's check again our data frame. So you can see right now there is around 2191. Yeah, that's good. And even you can see there is a lot of, okay, before that you can actually I have removed the column which I needed to remove. So you can see there is like first SC, and you can see it's like the non-null, and its data type is in 64, its data type is 64. You can see even there is object type. Object type are the categorical variable. In the categorical variable we have two types. One is the ordinal and other is the nominal. Ordinal means the number type. The number means, I will tell you, the number means see, okay, let me go in. Ordinal means, okay, so what, suppose, yeah, you can see here this is like a 1.5 story. So these are the ordinal type, because it has order. Okay, you can get a good example from here. These are the ordinal type, because it has ranking. So this is a very good, poor, fair, below average, average, above average, good, very good, excellent, and very excellent. So these are the ordinal ordi, ordinal data. And you can see here these are the flat, dumbbell, graven, bar, heap, mustard, mentioned, sale. So this doesn't have the order. So these are a kind of, okay, each order, but there's a lot of, just like the city name. The city name you suppose it's a Kathmandu, Viratnagar, Washington. So one city is not better than the other city. So in that case we will be using the nominal. Okay, so if you could have it easily. Okay, again we are checking the heat map if there is a null value or something. So there is no null value. Even we are checking the fireplace QU. So in fireplace QU there is like 40 to 20 null value, and which is not more than 50%. I thought that would be fine. Okay, so right now we are instead of going for one by one column, we are just taking the entire numeric column into one variable, and another the object column into the another variable. So we are sending into the list underscore num, and you can see here the list. So we are selecting the select. So in the numeric tab we are just selecting the data types in the data frame. In the df, you can see here in the df which includes only the object type. So we are just taking that column and saving it into the list underscore norm underscore column. Okay. Okay, here the like exclude means object. If you are excluding object, then we are only selecting the numeric value, because if you will be selecting like if you will be including the numeric type, then there is a lot of numeric type. There's like float, integer in our data set, so that would be a difficult task. So we will always do the easy task. So we are just selecting this into our and saving it into the list underscore obj underscore. So again we are checking the data types. Okay, you can see these are the integer type, object type, object type, object type, object type. Okay, you can see easily. So it has basically two values. So okay, suppose if there is numeric value and there is some missing value, then we will be taking the mean of that and placing in place of that. But if there is the categorical value, it's like good, very good, something like that, then we will be taking the value which has more number of frequency, that we will be doing by the more. Okay, so here we are writing one function. Okay, if you want, then you can go by the column by column, but otherwise let's try to act smartly and just write a code for the function. So we are naming this function as the fill na underscore all, and we are just passing one parameter here. So there is a 4 column in list, so we are okay df column field na, just we are just giving the value and we are placing it by the mode, and implements equals to true. Implements, and there's always like the implements equals to true and implements equals to false. Implements equals to true means they are really going to in place in the data frame. If it is false, then it will not affect the data frame. So we are implementing the exact above to get rid of the missing values. So I have implemented this function, and again we have we are checking again df dot is any of a sum. If it does have any sum, so there is no more thing. So we cannot see like 80 columns, not 80 columns, maybe around 75 columns. So we'll be checking by the heat map. So even in the heat map you can see it doesn't have any null value. Okay, so these are the list underscore object underscore column. So we have just saved our previously all the object type. So you can see the in the object type you can see there's a lot like norm feed norm something no yes good. Okay, so actually computer cannot compute the numeric sorry, the computer cannot compute these string values. So for this we will be converting this, we call it a categorical variable. So we will be converting this categorical variable into the dummy variables, or we can simply say we will be converting it into the numeric value. Okay, for this we will be using the one hot encoder. Okay, even I have checked the length, its length is 29, and if there is any missing value still, okay, my computer might do a wrong thing, so we will be dropping dropping that row. Okay, so we are doing the one hot encoding. So it's like pd dot get dummy the above list underscore this and drop underscore first. That's always the true. So from here we are creating a dummy variable. And what dummy variable? Okay, I will tell you from here. Okay, if you want, then I can. So let it paint. Okay, suppose if there is a two column. So okay. Okay. Suppose if there is a two column. which has male and female. Okay, which has male and female. Okay, which has male and female. Basically, this we call it, we can call it the column as a gender. Okay, suppose this is the gender column and it has lots of data as male, female. Suppose there is like again male. Okay, so female I think. Okay, and suppose if there is gender like okay female, we can have this, or we can even have this into one column. This suppose this is the gender and we can have male, female, something like male, female, and suppose this is the gender column. Okay, so what does a one hot encoding will do? It will transform into the, so here is only the male female, so there is only two values. Okay, so it will be converting the male into a one column and female into the another column. Suppose here is the male and here is the female. Okay, you can see for the male, if there is male, then it will be writing the 1. So in the female there is the 0 at the first. Okay, and if there is female, then it will be writing here the 0 and 1. Okay, and it's the male, again male is 1, and again in the female it will be 0 even if there is a female, so there will be 0 and in the female it will be 1. Okay, so basically we will be doing these, and if you will look closely, then I don't think we really need two columns to describe the male or female. Suppose if we don't have this male column, then only by the female, if it's like a 0, then we can simply know that 0 represent male, and if there is 1, it means it simply represent female. So I don't think we need a two column. So every time we will be like dropping the first element, so we will always drop the first element because only one column is effective. Okay, so I have always dropped the first, and again, so it has saved its value into the dummy column, and even you can see its shape. Even in its shape, it has like almost 200 columns, so it has 91 hot encoding, and it has a lot of dummy variables. So after this we will be concatenating the dummy variables and our data frame. Okay, so that both of them will concatenate by the column name. Okay, even we are checking the shape, you can see earlier the shape is 200 and the df shape was you can see in the df shape it has a 75, so its length will be 275. Okay, even I'm checking right now df.info, but it's not showing because it's saying it is giving us a message that 2.2 plus MB. It has been like 2 plus 2 MB, which cannot be found. So at first let me do this with the log. If I'm checking if there is any duplicate column, okay, then it will be removing all those duplicate columns. So let's check again. It's safe. Okay, it's check is same, and after this actually suppose if we have concatenated, okay, you can see you can see if there is a female, and if we concatenate these both, and this is the gender and this is the female, and Right now we have done one hot encoding of the gender to the dummy variable female only. So I don't think we need this gender value, gender column. So I'll be deleting this gender column, and we have saved those categorical variable in the list underscore object underscore column, and we will be dropping all those column in the data frame. Okay, so I have drop so we have deleted that the data frame. So you can see the list underscore access equals to 1. So we have easily done it. And you can see in the remove the again we are seeing is there any duplicate value? No, there is not a duplicate value. Okay, right now we'll be splitting our data into the training and the test set. Okay, so in that before going to that we'll be first checking the shape of a y. So y shape is 1460. This is the training, the sale price. Okay, so we have simply 1460, and you can see in the, if you look clearly, we are using the iLock of the pandas. And so at first, especially this before the comma, this is used to select the rows. So I will be selecting the all the rows up to 1460, and after that this represent we are selecting all the columns. And even the iLock we are selecting the from 1460, from 1460 we are selecting all the rows, and we are obviously we are selecting all the columns. Okay, so and in order to predict that is a dependent variable, that is the sale price, so we'll be setting the sales price into our training data set. So let's check the shape again for 1460. If there is a mismatch between the training and the X train and between the Y train, then it means some error, and which is very, that's not good actually. Okay, so before this, and they have told us that we need to do a gradient. Where's that? Okay, that they have told us that we will be using the gradient boosting, and even there is random forest. I want to be random forest because I have known it has a lot of variance, and it is not better than the gradient boost. So we will be using the Xgboost. If in your system, if you have not installed the, okay, you perhaps might not install the Xgboost, then you might go to the cmd command, and simply you will be writing the pip, okay, set pip install. You can see its name is Xgboost boost, and then you need to press the enter. Actually I have already installed, so I'll be closing this window. Okay, if you want then you can do. And and again I mean to have the more accuracy, I will be using the hyperparameter optimization, because before this, as I have saved in the Kaggle composition, you can see before my score was 0.14354, because I have not done the hyperparameter optimization. Then I really did the hyperparameter optimization, and my score just jumped out. And see, so hyperparameter optimization means we are selecting the best, the best means the best set of optimal parameters in the XGBoost. So when you are using the hyperparameter optimization, then your value must be in the smaller number. It shouldn't be like the 7, 8, 9, 10, 20, 20 number of estimator. You cannot do that. If you will do this, okay, then you must have a nice computer system. If you don't have a nice computer system, then your system might get into trouble, and it will keep executing maybe for 5 days, 10 days, maybe for year, month, and that will be of the no use. So choose your hyperparameter on the basis of the computer. Maybe it will take around Maybe you can choose the numbers like the 10, maybe 10 fold cross validation, but don't go for the more. Okay, and I have set the learning rate, this mean with the child, the base score, and 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 this parameter we are saving into the hyperparameter grid. Okay, so here we are doing the four four-fold cross validation in the by the random search. And random search, actually this is a great, this is very useful for the cross validation. And for this we are selecting and we are randomized search CV, so it will be giving us the best of the best value. So we have set its estimator, we are just using the regressor. You can see the regressor, these are the estimator. Xgboost, this is the regressor, this is the name of our model. And you can see after this, okay, parameter distribution will hyperparameter here, the hyperparameter we have, which we have given c equal to 5, it doesn't. Okay, actually I have left one or two the parameter, but if you want you can give all those parameters. Okay, because it will take you a long time for doing this. And after this, after describing this our source model, then we are just fitting it into our model, that's the random underscore cv dot fit x train and y train. Okay, so when you just enter this, then you might get like the parallel and underscore job equals to for using backend something something. Okay, then don't think that your computer is in any kind of trouble. Just wait for 5 minutes, 10 minutes, 20 minutes on the on your PC side. So for my PC it took around 18.77 minutes to finish. Okay, if the computer is fast, then it might take around 8 minutes, 9 minutes. It depends upon your PC configuration. So after this, uh, it will be giving you the best of the best score. So if okay, there's one more, this best estimator with the best estimator, we can see there is like base score equal to 0.25, booster equal to GB3. So it has given us the best estimator and the best parameter for the Xgboost regressor. So again by taking the, you can see the base score, booster, and you can see each and everything. We are just taking the same as here. Then again we are remodeling. Okay, even now, and we have remodeled the Xgboost. And after this, let's just fit into our training and the test, so into our x train and dependent variable and in between the independent variable. Okay, after this successfully, after this we need to predict the price of the x test, because we don't have the y test, which will be tested by the Kaggle. So after predicting the x underscore test, we are saving into the y predict. After y predict, so this is the name of it, the column, and we are saving this. So this is the list actually. Okay, so we are so we'll be saving this into our uh, okay, we are converting it into the data frame. Okay, after this we'll be exporting it to the data frame. You can see there's like the, okay, at first I have got the sample submission which I have downloaded from the Kaggle. And after this we are just concatenating the sub id and prediction to the new. After the new, okay, so this is this, okay, we are saving the id into the, so we are just, you can see we are just taking the id of the sample submission. And after this, so we are only taking the one column of the sample submission, and that is, okay, I can show you. Okay, because they have given us the format, in which format there must be a one id and one there must be the sale price. So we will be selecting all this id only, and after that we will be giving the our prediction sale price predicted. Okay, and we'll be naming this id and price. Okay, okay. See here, so again we are setting the column name as the id and the sale price, then we are exporting. Here we are exporting outside uh, to the name sample underscore submission one dot csv index equals to false. If you will do this much, then you are ready for the Kaggle. So after this, it will save into the name. So you can see its name is sample underscore submission one. Okay, that CSV file. Okay, you always need to save the Kaggle result into the CSV file. So after this, okay, you can see this is our result. So you can go to the location in that exact location, and you need to make just like submit prediction. Okay, and you need to go to the file where you want to. Okay, you can select the files anywhere. Okay, so this is sample one. You need to just open it because I have already submitted, so it will show me one more time selected with the same accuracy. So I won't be doing that, and if you want, then you can write the description and you need to make a prediction. After making prediction, you will get your score and even your position in the leaderboard. And I think if you there's a lot of people who will be telling that the feature engineering, and this is like the feature. I have done the little bit of feature engineering, not too much of the feature engineering. And for this feature engineering, I will be making another video in the machine learning. Okay, okay, I'm just working on that, and I will be publishing that soon. So for that, please do subscribe, like, and if you have any kind of query, then feel free to ask me. Okay, I will be giving you answer maybe in the 10 minutes, 20 minutes, but I will be giving within 1 hour. That's my promise.